Oh, hi there, everybody. I hope everybody's doing good. We are going to talk about equivalent quadratic forms today in this video. Most of you, this is going to be review for. Some of you, it might be a little bit more review than others, but just a few slides to kind of get us into it and get us ready to get some practice in. Remember, there's a note sheet with this that corresponds. So if you want to print that out, pause the video, make sure you got those. Or if you just want to do a separate sheet, that's fine too. Let's get into it. So we have three equivalent quadratic forms that we're going to discuss. The general form ends up being y equals ax squared plus bx plus c, where if we're actually going to graph it, a is the scale factor, b would do not just left and right, but it actually moves it, could move it up and down as well, and then c is the vertical shift for sure. So not that big of a deal right now, or we're not going to really focus on that, but just so that you know with that part. Vertex form is in the y equals a x minus h. Don't forget the squared. That's what a lot of people forget. And then plus k, where a again is the, I'm going to move this down on the bottom. I don't want to scrunch stuff. Scale factor, h and k are the vertex, which is why this is so cleverly named vertex form. Last one, factored form, y equals a, x minus r1, and then x minus r2. Okay, where a again is the scale factor. That makes it either narrower or wider, and then r1 and r2 are the roots, the zeros, or you can also call those the x-intercepts of the quadratic, which again, there could be 2, 1, none of them. So it kind of depends what we're given or what we know, all that good stuff, to be able to give us one of these forms. And we should be able to bring, for example, these two, vertex and factored form, back to general. And for sure, we should be able to bring general back to factored. Okay, so we're going to be manipulating. That's going to be part of it. So that'll be our first example, and then we'll get kind of an application piece. Okay, so here's one of our parabolas on here. So let's write the equation in vertex form, write it in factored form, and then go ahead and convert each to the general form. I'll give you a chance, pause the video, give me that a, b, and c, and then we'll go over it. All right, well, I know the vertex. Vertex is at 1, negative 4. So that should give me enough for the vertex form, where I go y equals a, don't forget about that, x minus h. Remember, I'm doing the inverse of that, so that'd be minus 1, and then minus 4. Now, a big question, especially if you're scratching your head or not quite remembering, is how do we figure out what that scale factor is? Well, if we look at the parent function, y equals x squared like that, remember there's a little bit of a commonality with, if I started on the, I better use a different color, huh? If I start at, which would be at the vertex, and then remember it goes over 1, up 1, and then over 2, up 4. So as long as if I don't have it any more narrow or anything like that, the big one is going from vertex to the next point. And if it goes over 1, up 1, which this one does, if I'm given a graph, I know that the scale factor is 1, or there is no effect. If I don't have that, or I'm not sure, I can always plug in a value for x and y and solve for a. The only kind of limit I have is that if I'm using vertex form, I cannot use my vertex because it's already in my equation. The reason is because you'll get double zeros, and then if you try solving that, it'll give you an error for that because you can't divide by 0. So let's pick a different one. Let's just use one of our roots. Let's call that 3, 0. So I know that y equals 0. A is what I'm trying to solve for. 3, and I even did that. Remember the squared, minus 1, squared minus 4. So I'll go through the process. 3 minus 1 is 2, squared is 4. So this whole piece is going to be 4. Add the 4 over to the other side. So I get 4 equals a times 4, which again, if I divide by 4, just like we saw on the graph, I get a scale factor of 1. Okay, and I can do that also with factored form, which I can do here. I know the two roots. Just remember when I plug this in, y equals ax, I do the inverse. So like the first one, if it's negative 1, goes plus 1. And then if it's positive 3 for the other root, I'll put it at x minus 3. Okay, same process for solving. The only rule now is that I can't use my roots here to plug in, just because, again, I'll get a 0 on one of those, and 0 divided by 0 just won't work. So in this case, then, I'll just flip-flop it, use the vertex. Okay, so again, let's just try that. Y equals a, and then this is 1. So 1 plus 1, 1 minus 3. So I got negative 4 on this side. 1 plus 1 is 2. 1 minus 3 is negative 2. 2 times negative 2. So I get a negative 4. Hopefully you can see it. A again equals 1. So I have a couple ways to think about this. Both of these forms I can find it. Just remember, because I even forgot about it, the squared, especially in vertex form. And then I can also have the observation on the graph, okay, if it's there. So that's how you can find the scale factor for your piece there, which is a little bit implicit with there. So show both equations equivalent. I might have to do another thing. So let's, or do another slide, but let's try and get these both on here. So if I do the first one, so since I don't need a anymore because I know what a is, y equals, so in this case, x minus 1 squared minus 4. Now I just have to solve or expand this to do that. So I have to put that in. So whatever process you want to use to get this, if you want to use it and think of it as x minus 1, and solve that way, or if you can do the shorthand way where I know this is x squared times that by 2, so to get your b, and then square that to get your c, because I do that times that, so plus 1, and then I still have that minus 4. So then I get y equals x squared minus 2x, and then 1 minus 4 is negative 3. Now, if I did this right, I should get the same thing when I have factored form, and let's do that here. So I have y equals, remember a is 1, so I don't need it, x plus 1, x minus 3. Again, FOIL that out, y equals, and if you want, again, the shorthand version, add these together for your b, multiply them for your c. So I don't have to do the whole FOIL and combining. Again, I get both of them, so there's factored form. So either one of them are going to give me the same thing, which makes sense. They're the same equation, just in a different form. That's why they're equivalent quadratic forms. Look how we said that. Okay, so that's one thing we should be able to do, is manipulate and go through all the forms, or kind of tweak them and change them, or find the important pieces and all that stuff and know the difference between them. Part 1. Second one, let's apply a little bit and use kind of some of our stuff we've done this week, which is writing some of these equations and getting the stuff that we need. So why don't you take a second, read this, and then if you want, you can go right to solving A, B, C, and D. I guess I forgot to put B. It'll be on your sheet there. So go ahead and give me those ones. So copy and complete the table, write the equation, and then answer C and D for that. I'll let you pause the video, take your time, and then we will go through it. 3, 2, 1, go. Okay. If I get this now, hopefully you guys did not put 75, because I know we're trying to get to 80, but remember, if this is a rectangle, if this part's 5, let's call that the width, this has to be 5, so now I'm using 10, and then this length, remember there's 2 of those, so I need half of what I'm looking for. So really I'm only looking for 40. So then I can go 35, 30, hopefully you can see the pattern, 25, 20, and then 15. Okay, I want to find the area. I have the length and width, so just multiply both of those. 5 times 35, 10 times 30, 15 times 25. I'm going to run out of room here, so I'm going to kind of stay room. So first one would be 175, then 300, then 375, 400, 375. That should be a little bit of a key. When I look at that, I said, whoop, there's my vertex. Okay. So I know that that's my high point, okay, my max or my min. All right, so we got that. So now our big piece is that we got to write the equation out. Well, it says in there, just like it says in there, let x equal the width, let y equal the area. So I'm just going to use meters squared like that. So let's see what you got. So I'm going to go y equals the area. So that means that I'm going to basically be putting length times width. So I got to represent length and width in terms of x. So that means that I already know the width. Width is x. So how would we write the length? Well, the length, just like we said in kind of our table here, is that whatever I have for the width, I'm going to do 40 minus whatever the width is. So then I would multiply it by there. Okay, it's not 80 because it's not the total. It's just one side. Remember, one side is half of what I'm looking for. That's why it's 40, not 80. Okay, so that's my piece there, which I could actually distribute and get it into a general form, because right now this is in answer fill in the blank. That's in factored form. Okay, and I can put this in general form by distributing that. So I know I'd have negative x squared plus 40x. So there's general form. All right. If I'm looking for C, so if C is asking for which width provides the largest possible area, well, that would be the vertex of the parabola, meaning it's the high point, so that's going to be the highest piece. Luckily, it's on our table already. So I know that the length that I'd be using, width. So the width I would use would be 20 meters. And then what would the area be? Well, that means the length has to be 20 as well. So then my area is 400. Let's use some units to be mathy on that. 400 meters squared. That's the most I can get. Okay. And the last one, I want to see what the results are when the area is 0. So in effect, I'm looking for my roots. So that means I need it in factored form. Hey, look at this. We already had it. So that means that I have to go through the process of finding my roots. Remember, I just set each one of these equal to 0. Well, x, set it equal to 0. Hey, found one. And then the other one, 40 minus x, also has to equal 0, because that's the area that we want. Go through solving. Minus 40, divide by negative 1. X will be 40. Okay, so I know at 0 meters and 40 meters, those are the widths that will give me 0 meters squared. Okay, because I won't have a length. Or I'll have a length, but I'm multiplying by 0, because there won't be, in this case, there's no width, and in this case, there's no length. So I can't have an area with that. Okay, that's about it, guys. So I'm taking a lot of assumptions with that you can factor, you can FOIL, you can get all that stuff. You can find the roots, understand the vertex. If you need to, please make sure you're graphing, use Desmos on there. I have that link on the homework or on the practice for you. So please make sure you're taking advantage of that. If you have any questions, let us know. Otherwise, have a great day.